on things on and off. And the last 3 days of the class, you actually tear it apart, beat it up, and learn how to penetrate into them. So if you want more, there's more information about how to get training specifically on SCADA security. So here's the last few comments, and we'll start taking some questions, some answers, question and answer time, is that the power generation, transmission, and distribution systems all require these systems to be up 24/7. So it's difficult to patch. Okay? In the past, these systems used serial protocols, special cables, and that stuff wasn't really that big of a deal. But now we have this convergence where a lot of this critical infrastructure is running on enterprise systems. Juniper, Cisco, Microsoft. Now it's looking like a corporate system. In fact, some of these SCADA systems, when we scan it with a vulnerability scanner, it looks just like a scan that came back from a corporate system. So now that it's starting to look and feel like a corporate system, the problem is we don't have the same security features we take for granted on the security side, on the corporate side. When you go to work every day, you know that you're going to have to change your password every 30 days. You know that you're going to have antivirus on your machine. You know that there's probably going to be IDS, there's probably going to be logs monitoring what you do. You have acceptable use policies you sign on what you can and cannot do on your machine. There's a whole host of security controls that we all take for granted on your machines that you use for your email and your work. On the SCADA side, those machines look and feel the same way. They're Windows machines, they're running applications, they're doing the same stuff. But they don't have antivirus, they don't have IDS, they don't have the ability, they're not turning on the logging, and so they don't have all of the same type of controls that the corporate side has. And what we found is that the NERC CIP security compliance regulations is making a small dent into the problem, but certainly not enough to hold back a determined attacker. We're starting to see advanced persistent threats creep into SCADA infrastructure, whereby some of the SCADA systems owners and operators, they don't think they're actually in control of their own system anymore. So someone has been in our system long enough that when we go to re-image the system, the image has already been owned. So we don't even know how deep this infiltration has gotten. And we're there today already. So the research that we and other independent security firms have performed on this infrastructure has led to a situation where electricity can be free. I mean, the concept of the title was to just trigger your mind and to open your mind into thinking, those who have intent and motivation can do this type of stuff. It's not where we have to have a proof of concept anymore. It's already been proven. So there's information if you guys want to ask any questions later. Always respond to emails. It may not be the exact same day, but we do respond to any questions you guys might have. And with that, I'll open up to any questions from the audience. Sure. Yes. Yes. The question that he asked was a lot of the smart metering systems are leveraging the cellular data packet systems, right? And was the second part of your question was? And the base station, yeah. Can you sniff the traffic going from the meter back to the provider if it's using a cellular system? Well, thing is, you're going to see other presentations done today and tomorrow that talks about man-in-the-middle attacks on cellular data packets. So just because you're using like a Verizon or AT&T system to transfer data, it's quasi-private. You're getting a private IP address within their system, but it's certainly, you can't just put all your faith in their system. It's certainly a little bit more secure than traditional RF systems like 900 megahertz with basic encryption on it or Zigbee, but you still have to worry about if that can be hijacked in the middle. Yes, yes. The question was if an attacker had physical access to an RTU or a PLC, can they go back through that channel backwards to the control room? Absolutely, absolutely. In fact, sometimes we're hired to do a red team attack, whereby the company says, I don't care how you get into our control room, we want you to break into our control room. And the best way to do it is not attack the control room head on, because they have fences and guards and gates and cameras. Go to a remote substation or to a remote microwave tower. some remote part of the facility, that infrastructure, and break in there because you're on the wire at that point. If you're at where an RTU is and it's a TCP/IP connection, you can ride that connection back to the control room very simply. What was that again? Which, like BGP you're talking about for? Oh, oh. For redundancy, yes. What we found is that the SCADA environment typically lags corporate IT by about 5 to 10 years. And so, whereas now, VMware virtualization is commonplace for corporate IT infrastructures, virtualization is just starting to be embraced by SCADA because it's a trust factor. It's like before I had this big pig iron machine and it's running my SCADA system. And if there's a problem, I have another machine sitting here I can turn on. And so it's this whole thing of trusting this virtualized system to virtually run my operating system and applications. And also, the SCADA applications have to be tuned to work actually in a virtualized operating system. We're starting to see that, actually. Some of the smaller SCADA systems that run like water plants, gas compressor systems, and those Windows applications such as like Wonderware, Intellusion, SciTech, those systems have embraced virtualization. Some of the larger vendors like ABB and such are just now starting to think about it. They don't actually have a full-blown virtualization, a virtualized SCADA environment yet. So I suspect over the next 3 or 4 years, it will be the same, it'll follow the same cycle as the corporate IT side. Other comment? Yes, so the question was, have we seen any SCADA-specific firewalls that do deep inspection of the protocols? So we are seeing companies leverage multi-layer UTM devices, such as like Cisco ASA or Fortinet, different devices that have the ability to take apart the packet and inspect it. However, and there has been some work in actually doing SCADA protocol analysis work and plugins. There's a company called Digital Bond that was hired, actually worked for the US government about 3 or 4 years ago, that wrote signatures for Modbus, I think for DNP3, and a couple of the other SCADA protocols. And most of the corporate security vendors have taken those SCADA plugins and put it into their firewalls. So you can use deep inspection firewalls and then put the SCADA-specific signatures into there. In fact, there's also a lot of people that we've worked with that have actually taken classes on developing custom NID signatures and then have written their own signatures for certain events. Now, there's also a company called, there's a firewall device called the Tofino firewall that was actually written for SCADA systems, and it does actually inspect the Modbus protocol itself. So in the Modbus protocol, there's 16 function codes to read and write registers, read and write coils, within a SCADA system, and they have the ability through a GUI to where you can set up which coils and which registers you want to deny the ability to read and write from. And the firewall will then actually go deep into the Modbus protocol, and if you're requesting to read or write data to a specific register in the PLC, the firewall has the smarts to actually stop the packet. And that's the first one we've seen. There may be others out there. Yes? One-way data diodes? Yes, we have. The only industry we've seen that in is in the nuclear industry. They have, the nuclear industry has very strict controls around what data can move forward and back. And from the control system out, it can only go outbound. So we see in the nuclear field one-way diodes as well as air gaps, but we have not seen any of that use of technology in any other sector. That's right, exactly. Oh yeah. In fact, I think in 2005 we wrote a white paper, and it was 6 ways to protect the perimeter. And we put that, one-way diode, push a secure file onto a server and let someone else pick it up. We even went down to the road of actually building a prototype for a system that only transferred data serially. So the data was collected from the SCADA system, and then there was a serial RS-232 cable from that device to another server, and it pushed it over a serial connection. So you can't even hack backwards. It won't propagate through because it's a non-routable protocol. So we produced that as a kind of a proof of concept as well. And we haven't had any companies come back and say, hey, that's interesting or anything, you know. Yes. Yes, exactly. Anyone else? Questions? Yeah, the waste and AWWA is kind of been taking on that as kind of the body that looks over waste water and wastewater, and they're looking at the CFAT standards for chemicals, which was developed by DHS, and they're starting to take that on and embrace that for the water industry. And if you look at the CFAT standards, there's 19 components of it, and only one, which is Section 8, deals with cybersecurity. So they're really much more concerned about someone dumping something in the water or someone stealing chemicals to make weapons out of it. So DHS, if you look at the DHS standards and you look at the NERC CIP, the DHS standards are mostly physical and one little piece about cyber. It says you must always be in control of your control systems, and if you had an attack, you have to prove that you were in control. So basically it's very vague. It means basically you need to do enough due diligence to put in controls in place to know who did what. But if you look at the NERC CIP, it's 002 through 009 is all these standards are all cyber and then one physical. So the electric grid is much more concerned about a cyber attack than a physical attack. So it does vary by vertical. Anyone else? I think that will wrap it up. You guys go. Thanks a lot.